All across the UK, there are 90 teams working on Retrofit for the Future projects. This is a competition run by the Technology Strategy Board looking at advanced refurbishment in social housing. We're here in Balham, South London, to see one of those projects. Let's go inside and have a look with Bob Pruitt of Pruitt Bisley Architects.
As you can see and probably hear around you, we're lining the inside of the house, lining it for insulation purposes and air tightness. You can see a bit of wall parging here on the staircase, and then going through to, this will be insulated beyond, and then over the insulation, OSB sheathing continuously to give us good air tightness. That extends up to the ceiling, and if I take you through here, this section of wall behind me shows a piece of insulated wall, which is party wall, with plywood sheathing in this case, which runs up to the ceiling. Again, the ceiling's been insulated, and that's been sheathed with OSB. And you can see the blue tapes, and you can just see the remnants of tape between dry and wet construction. So everywhere on the job, there's this continuity being maintained from one surface to the next to achieve complete air tightness. And we hope to get below 1 air change per hour at pressure test at 50 pascals on this project, which is still very unusual for retrofit. This pipe is the main soil pipe. We've moved that inside the building. Right. To make interfaces on the outside easier, because the other side of this wall is external insulation. We've taken the vent pipe up into the roof, and it extends around the rafters and up through an old chimney stack in the end. But to take circular pipes through simple planes is always a tricky air tightness issue. So we've used a proprietary grommet and plate at this point, which has then been sealed into the OSB with battens and hefty amount of silicone, which is sort of squeezed together on mechanical fixings. Right. So we've tackled the primary heating load fundamentally, looking to insulate the whole building envelope continuously from floor, wall, ceiling, and through the windows, and achieving continuity of that insulation. Because the front of the house is architecturally quite sensitive, and we're in the vicinity of a conservation area, on the front of the house we'll insulate on the inside, and we've taken some degree of care to maintain the continuity of insulation from the wall through the new sash windows and up into the ceiling. On the rear of the house, however, we'll use an external insulated render system. We'll be able to use triple glazed windows there. You can see the plywood sheathing coming down and extending across the sill. The window will be taped to the plywood along those two lines, and then that taped joint will be hidden by a sill board cut into the base of the window here, and a plasterboard finish which will extend over that tape junction and just form very neat sort of flush reveal at that point. One of the classic problems you come up with on houses like this are the joists which sit in the front wall, and if you're insulating on the inside, you have a conflict between the joists and the insulation and the air tightness, and a sort of a concern, latent concern, that the joists left in the wall may be prone to rot in the future as the wall possibly gets wetter in time. So we developed a sort of a joist hanger system which breaks that connection between timber and potentially wet masonry, so that two things are isolated. And then the timber to insulation detail gets dealt with using the OSB board, which goes through between the joists, and then each joist is taped to that OSB, which is still fairly labour intensive, but we believe will give us the results we require. Yeah, in this location, life's made easier in one respect because the outside of the wall is insulated, so we've not got a rot problem where the these joists sit in the wall.
Not a lot of moisture, yeah.
But we still have the air tightness issue. So in order to achieve a good air tightness connection between the timber joist and the plastered wall, you can see first job was to parge the exposed brickwork, which is the brown sand and cement there, and then tape the joists with this blue tape so that we could make an edge to the joist that could be stuck to. And then Contiga tape has been stuck to the blue and then stuck to the sand and cement, and then this pink plaster is applied over the top. So that should give us a completely sound air tightness junction at that point. The other classic problem, if you go to an external insulation system with render, it gets you at a lot of the sort of joist issues, but then when you bring that system up to the roof, particularly on Victorian buildings where there's quite a tight clipped eaves and tight verge detail, the insulation has got nothing to sort of finish it and to tie it back into the roof. And without taking the roof off to extend it over the insulation, which is quite expensive, you're left in a bit of a quandary. So at that point, that particular junction or interface, we've developed a kind of super fat wide gutter system. This detail section here shows the proposed sectionate and eaves. You can see the existing rafters coming down onto a wall plate and onto the brickwork here, and the existing tiles and eaves board there. We're not touching any of those components at all, really. We're not affecting those. We're installing insulation below the rafter line and allowing ventilation slots between insulation and sarking so that the roof breathes as it does at the moment. And then on the outside, this is the 280mm insulation that will be installed with a render finish. Just there is the existing position of current plastic rainwater gutter. So we'll simply take that off and fix on a new aluminium profile, much wider gutter.
We've just seen an excellent example of a retrofit for the future project. We're interested in hearing your thoughts. What do you think? Please get in touch and let us know.